check the sphere, no? That is root 10 GH divided by 1 second. Two particles, I think. So 1 second was. It was the sphere which is root of 10 GH by 7.
Okay, ma'am. Thank you.
Now we'll start with this was the next one. Can you see this slide? Equilibrium of rigid bodies. Equilibrium of rigid bodies. Can you see the slide? 11B.
Yes, ma'am.
Yes, sir. Okay. Just write those. Equilibrium of rigid bodies. See what happens. A rigid body can be under equilibrium if it is undergoes a translational motion. So it has translational equilibrium as well as rotational equilibrium, right? So for a rigid body, when the body is, boys, 1 second. When the body is rolling down an inclined plane, it has both translatory motion as well as it has both rotatory motion. When the body moves along a straight line path, it has only translatory motion. So for the motion of a rigid body, the equilibrium can be under there are two conditions for equilibrium of a rigid body. One is translational equilibrium. The net force acting on the object must be equal to 0. That is your translational equilibrium. For rotational equilibrium, the net torque acting on the object must also be equal to 0. We'll see how things are proceeding. Just write the conditions, boys. Equilibrium of rigid bodies. Equilibrium of rigid bodies. There are two conditions for the equilibrium of the rigid body. One is for translational equilibrium, net force on the object must be 0. And for rotational equilibrium, the net torque should be 0. Okay. Okay. The net torque must be 0. Now look at this. Look at the figure B. So, boys, this one is so one is the torque here will be anti-clockwise. Here the torque will be clockwise. So in a seesaw, right? Now what is torque? Boys, what is torque here? This is the weight of the person and this is the perpendicular distance L. So here the torque tau is equal to W into L. Same way here the weight of the person is W, The perpendicular distance is L. Even here the torque is W into L. So both the torques are equal but acting in the opposite direction. See, when the body is going to rotate, when the body rotates, here the torque is clockwise, here the torque will be anti-clockwise. So both the torques are equal in magnitude, opposite in direction. So the net torque will be 0. That is why in the first case there is no rotation. In the first case there is no rotation. Now what about here? Here the torque is the weight W into L. Here the torque will be W is equal to the weight into L by 2. This is acting. Now, are these torque the same? Both the torques, right? If I add, this is, say this is negative, anti-clockwise torque, we take it as negative, the clockwise we take it as positive. When you add these two never cancels off each other. So then in that case, the system is not in equilibrium. That is why the system undergoes a rotation. Is that not? This person will go down, the other one moves up, which means there is a rotatory motion about the axis of rotation, because the anti-clockwise torque is not equal to the clockwise torque. Same thing here. Here the torque will be more because the force gets added up. Here the torque will be less. So whenever the torques are not balancing, the body will not be in rotational equilibrium. Rotational equilibrium means this one. Neither the seesaw will move up nor seesaw will move down. There is no rotational motion. The reason is your anti-clockwise torque is balanced by the clockwise torque. 11B, is it audible for you? 11B. 11th standard?
Yes, ma'am. Yes.
What is the problem, boys? Okay, boys, sorry. Next, what is there for your? I don't know, boys, what is this chapter is totally tough. So anyway, principle of moments. So what is a principle of moment? If a body is in rotational equilibrium, consider the case of a seesaw, right? You have two persons sitting on both the edges. Now, if the seesaw is neither moving up nor down, which means if the seesaw is not rotating about the pivotal point, then that is what we call it as rotational equilibrium. So when a seesaw will be under rotational equilibrium when the clockwise moment of a force is force into the perpendicular distance, F into R, we call this as the moment of a force. Moment of a force is nothing but the force into the perpendicular distance of the point of application of the force and the axis of rotation. Was if a body is in rotational equilibrium under the action of number of forces, then the algebraic sum of the moments of the forces, moment of the force is what? Moment of the force is equal to force into the perpendicular distance. Right? Here, person A is applying a force of 800 Newton. He is at a distance of 1 meter from your pivot, which means the moment of the force will be 800 into 1. So that is what we call it as a moment of the force. Moment of the force is nothing but torque. Are you clear, boys? Are you clear? What is clockwise? This is clockwise moment. What is clockwise moment? Force into the distance. What is anti-clockwise moment here? Same way, force into distance. So what is the force applied in this case clockwise? What is the force? 800. What is the distance? 1. So clockwise moment is 800 newtons meter. What about the other one? 400 into 2, because the other person is sitting at a distance of 2 meters away from the axis of rotation. So both the torques have equal in magnitude but opposite certain direction. Hence, the body is under rotational equilibrium. Because if you don't understand this, you cannot solve a numerical which is going to come next. So what is moment of a force? You should know. Torque, in other words, we call this as the moment of a force. So what is moment of a force? So that is force into the perpendicular distance between the force and the axis of rotation. So in a seesaw motion, one end will have a clockwise moment, the other one will have an anti-clockwise moment. So I need you to write this statement when the body and this entire statement. If you can't write the was only these two should be written as the principle of moments. If a body is in rotational equilibrium under the action of a number of forces, here what are the forces acting? 800 Newton at one end, 400 Newton at the other end. So if a body is in equilibrium under the action of a number of forces, then the algebraic sum of the moments of the forces about any point is equal to 0, which means, suppose if I mark this as F1 and this distance as R1, this force as F2, this distance as R2. So what does it mean? F1 R1 must be equal to F2 R2. That is what it means. Must only the statement you take the statement. 11B, should I call out your names? Was only the statement is enough, then we'll go for it.
Understood.
So body is in rotational equilibrium under the action of a number of forces, then the algebraic sum of the moments of the forces about any point is equal to 0. That is, sum of clockwise moments must be equal to sum of anti-clockwise moments. Next one, I have taken it from your textbook. You can have the diagram and go through it. Fine, boss? Now look at this. No need for you to write the statement. Only the diagram is enough. Is that clear, boys? So consider a seesaw. A person is sitting at this point. Suppose if I have a person sitting at this point, yes?
Can you show the previous slide for me?
I'll take a screenshot.
Okay. Here, suppose if I have a person sitting at this point, he is exerting a force F2. Another person is sitting at the extreme other end, F1. He is applying a force F2. And F1 is at a distance of D1 from the pivot, because this is the point about which the seesaw is going to rotate, right? F2 is at a distance of D2 from the axis of rotation. Is that clear, boys? So your weight will be acting downward direction. There will be a normal reaction in the upward direction. So this is a rigid body. So in that case, for translational equilibrium, you have, suppose, listen, this entire thing is a metallic rod. Another light rod is this one. Suppose if I mark this as AB. So AB becomes a light rod. You take a meter scale or any metallic rod at one end, let's say at end B, you're applying a weight. That weight gives a force of F2. And at other end, you apply a force of F1. Then you are keeping this entire metallic rod on a knife edge, right? So about the knife edge, the body is going to rotate. Is that clear? Suppose if you don't want the body to rotate, for translational equilibrium, it should not move. Translational equilibrium means the body should not move up or in the upward direction or the downward direction or sideways movement. Then the total force acting on the body should be equal to 0. So if for translational equilibrium, neither the metallic rod should move in the upward linear direction, either along x-axis or along y-axis, then the total force should be equal to 0. So minus F1, because this is tending to move in the anti-clockwise direction, this will be in the clockwise direction. So minus F1 plus N, boys, please understand all the forces which are acting in the downward direction, I have taken it as negative. All the forces which are acting in the upward direction, I am taking it as positive. So which are the forces which are acting in the downward direction? F1 is negative, F2 is also negative. So what is the other force which is acting in the upward direction? N. So all these forces should become equal to 0. Or I can write F1 plus F2 is equal to the normal reaction. Now if this condition is satisfied, this metallic rod will not move. I think I need to call out you people.
Ma'am, what part of the slide we have to write? Do we have to write the statement?
No need to write the statement. What you need to do is only you can write only this much statement is enough. Consider a light rod of metal, a negligible mass, which is pivoted at a point along its length. That's enough. Then draw the diagram. Then write for translational equilibrium. The net force must be equal to 0. Hitesh, Jatin, Hitesh and Jatin. Hitesh, Jatin. I need to call you, boss. Where is Hitesh? Let me check. Jatin? Praveen? Praveen?
Ma'am, did you call?
Is it Kavin?
No, ma'am. It's Nabil. I thought you called me.
Is this Nabil?
Yes, ma'am.
Nabil, I didn't call you Nabil. I just wanted Hitesh and Jatin.
Oh,
Hitesh,
okay.
Jatin. Jatin and Hitesh, what is happening? Boys, I cannot take attendance in a class. Dheeraj, Dheeraj,
Yes, ma'am.
Rishit, Rishit, Rishit.
Yes, ma'am.
Okay, Rishit is there. But someone sent a message to who are these boys, Jatin and Hitesh. I'm wasting my time. Now for rotational equilibrium, the moment of the force should be, when you add up the moment of the force means the net torque. Because moment of the force is just moment of the force is torque. The net torque should be 0. So you have tau 1, you have tau 2. Both are in opposite direction. So I can write here tau 1 is equal to the force and its perpendicular distance is d1. Here tau 2 is equal to F2 into d2. So the net torque F1, sorry, tau is equal to tau 1 plus tau 2 should be equal to 0, or I can write F1 d1 must be, sorry, plus F2 d2. So one will be negative, the other one will be positive. Generally, we take the clockwise moment as moment of the force as negative, so anti-clockwise as negative. So minus tau 1. So minus F1 D1 plus F2 D2 is equal to 0. Boys, net tau 1 is plus tau 2 must be equal to 0. So what is tau 1? F1 D1. What is tau 2? F2 D2. The anti-clockwise, it is up to us what we take it as the sign convention. If I am taking this as anti-clockwise, torque as negative, then tau 1 will be negative. Clockwise torque will be taken as positive. So tau 2 will be positive. So I'm taking this as positive, this as positive, this as negative. Boys, continue with your work. You can see the PowerPoint presentation.
Yes, ma'am. Yeah.
Hello, ma'am.
Yes.
Yes, ma'am. This is Kavin. Yes, ma'am. My laptop is slow, so I couldn't answer earlier. I was trying to unmute.
Jatin? Is it Jatin?
No, ma'am. This is Kavin.
Boys, I'm just calling Jatin. Some noise in the background right now. Okay. Is the teacher making a noise at the background? Jatin, then who is the other person? Hitesh. Boys, others carry on.
Ma'am, the diagram that's given here, it's the diagram for the previous one, right? For translate.
Same diagram. Same diagram.
So for rotation also same thing?
Same rotation. It's
Okay.
also same. This is anti-clockwise moment of the force. That is, I take this as tau 1 to be negative, clockwise torque, tau 2 to be positive. So tau 1 is equal to F1 D1, tau 2 is equal to F2 D2. So your net torque should be tau must be equal to tau 1 plus tau 2. So tau becomes equal to minus F1 D1 plus F2 D2. So that must be equal to 0, or I can write F1 D1 is equal to F2 D2, or F1 by F2 is equal to D2 by D1. Have you completed, boys? So if this condition is satisfied, your metallic rod will not rotate. That is the condition. For rotational equilibrium means what? When tau 1 becomes equal to tau 2, the metallic rod will not rotate. It will be at equilibrium. Is that clear? Shall I move for the next one, boys? Shall I move for the next slide? Johan, Jonathan, Johan and Jonathan.
Okay, ma'am. I finished this.
Now we'll start with the numerical. Now you are going to do the numerical. Look at this, a metal bar, 70 centimeter long and 4 kilogram in mass is supported on two knife edges placed 10 centimeter from each end. only this part of the diagram. Was now look at the question. A metal bar. So I'm having a metal bar AB of length 70 centimeter long and 4 kilogram in mass is supported on two knife edges placed 10 centimeter from each end, which means if I'm placing a knife edge K1, now that should be placed at 10 centimeter from, so 8, this is 10 centimeter was from here to here 10 centimeter. Then I have to have another knife edge K2. Abhishek, 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 Austin, Abhishek, Austin.
Yes, ma'am, this is Abhishek.
Okay, Abhishek. Right, from point B to the other knife edge, what should be the distance? From the knife edge K2 to the point B, what should be the distance? Look at the statement, a metal bar 70 centimeter long and 4 kilogram in mass is supported on two knife edges because this metal bar is lying on two knife edges K1 and K2. The knife edges are placed 10 centimeter from each end. So from point A, the knife edge is 10 centimeter away. So from point B, the second knife edge, what should be the distance over here? Did you read the statement, boss?
Ma'am, from both
10?
sides, it's 10 centimeters, 10
Each.
centimeters away,
Correct,
right?
correct. Next, look at this. The weight of the body of the metallic rod is 4 kilograms. So we'll consider this as the center of gravity, this point as G, right? From G, you have a weight W. What is the weight? 4 kilograms, correct, boss? The weight of the body is 4 kilograms. So generally we say the weight of the body is somewhere at the center of gravity. The entire weight is concentrated over there. Now, Hitesh, Jopal, what is the distance between A and G? AK1 is 10
Yes, ma'am.
centimeter. Okay, BK2 is 10 centimeter. I want what is the distance between AG? A to G.
35.
Yeah, because the entire length is 70.
Yes,
So what is the
ma'am.
distance between BG? What is the distance between BG, B to G?
B to G.
See, always the center of gravity will be at the central point, 35.
Yes,
Because
ma'am.
the entire was
Entire
G is the
piece.
midpoint of AB. G is the midpoint of AB. AB is 70, so A to G is 70, 35. Are you clear, boys?
Yes,
Are
ma'am.
you clear? Okay. Now look at the next part of the statement. A 6 kilogram load is suspended at 30 centimeter from one end. So I'll also say at point P, the 6 kilogram load. Say I'll mark this as W. That is 6 kilograms. Right? It is suspended from one of the end. Say I'm suspending it from end A. So from right, a 6 kilogram load is suspended at 30 centimeter from one end. So what is the distance A to P? What is the distance from A to P? Surya, what is the distance from A to P? P is the point
30,
where I'm
ma'am, 30 centimeter.
okay, 30 centimeter, fine. Now what is the distance between PG, P to G? Surya, what is the distance between
Ma'am,
P
5
to G?
centimeter.
5 centimeters. Boys, are you clear of this question? First and foremost, diagram and the question. Are you clear with this? Are you clear?
Ma'am, G is the center of mass.
Gravity as well as center of mass, both the same.
Oh, okay.
So draw the diagram, boys. Draw the diagrams and then write all these values, then only then we'll go for only then we need to go for translational equilibrium and rotational equilibrium. Draw the diagram, write all these points. Now look at this, boys. The metallic rod is exerting a force on K1 and K2 because this metallic rod is balanced on the knife edges. The metallic rod is placed on the knife edges K1 and K2, which means this metallic rod is exerting a force on K1. Yes or no, boys? The metallic rod AB is exerting a force on K1, then K1 will also exert an equal amount of force in the upward direction. That is what we call it as a normal reaction. Here they have taken it as R1, so I'll take it as R1 itself. Same way, the metallic rod is on the knife edge K2. So it is exerting a force, the metallic rod is exerting a force on K2. So K2 will exert an equal amount of force in the opposite direction, that is R2. So is the diagram now clear for all of you? Is the diagram clear?
Yes, ma'am.
Now the next part of the question is for Yusuf, Vishesh and Zuhair. Vishesh,
Yes, ma'am.
Yusuf, okay, Vishesh and Yusuf, anyone, or Vishesh, Yusuf, Zuhair, any three of you, right? Now tell me, there are a number of forces, there are forces which are acting on the metallic rod. Now identify which are the forces which are acting in the upward direction. It can be any three of you can tell me the answer. Which are the forces? Normal reaction is a force, weight is a force, okay? So which are the forces which are acting in the upward direction? Vishesh, Yusuf, Zuhair, anyone?
R1 and R2.
R1 and R2 are acting in which direction? Upward direction? Yes, boys? Okay.
Yes, ma'am.
For translational equilibrium, the net force must be equal to 0. Is that for translational equilibrium, right? For translational equilibrium, net force must be equal to 0. For translational equilibrium, net force must be equal to 0. Okay. Now, what are the forces which are acting in the upward direction? Yusuf, what are the forces which are acting in the upward direction? R1?
Ma'am, R1 and R2.
Okay, R1 plus R2. Which are the forces which are acting in the downward direction? Which are the forces which are acting in the downward direction?
Ma'am,
Forces.
P and
Yeah.
G.
No, yeah, those are the points. What are the forces? W1 and W, right?
Oh, yeah.
Both
Yes.
are negative. W, okay. W1 minus W. Boys, are you clear? R1 and R2 are the forces acting on the metallic rod in the upward direction. One. So W1 and W are acting in the downward direction. So all the sum of all the forces should be equal to 0. Next period, I'm borrowed a class. One second, boys. Can you get me the value that will be of the value of R1? Okay, boys. So
Is
break
it
time
100
now.
Newton?
Yeah, you have to. It will be in kilogram. You have to multiply by 9.8. Anyway, boys, I'll continue with this. You have a break, right? Anyway.
Thank you, ma'am.
Thank you, ma'am. Thank you, ma'am.